Hi everyone, this is Mrs. J, and this is our last section in our unit about circles. So today we're going to learn how to write equations of a circle. So we already know how to write equations of different types of graphs. We know that to make a linear equation, which again makes a straight line, we have the equation y equals mx plus b. We know for a quadratic equation, which makes a parabola, we have this form y equals ax squared plus bx plus c. So every type of graph has a different type of standard equation. So today we're going to focus on circles. So we know that a circle is a set of all points on a coordinate plane that are a fixed distance r from the center. So it's essentially saying if we have a center, all of the points are exactly r units away, which is our radius. So if you traced around this radius, you would get your circle. So the equation of a circle that has a center at hk and a radius of r can be made with this standard form. So it's x minus h squared plus y minus k squared equals your radius squared. So a few things to point out. If your h value is positive, you're going to see a minus sign in your formula. If either of these values are negative, these will actually turn into plus signs. So the sign that you see in your equation is actually opposite of what's actually happening at your center. The second thing I want you to be careful of is the radius. The value that you see in the equation is actually always going to be our radius squared. So make sure you keep that in mind. So for example 1, first we're asked to write an equation of a circle with a center at 6, 7, and a radius of 4. So we're simply going to plug in these values for h, k, and r. So our formula would be x minus 6 squared plus y minus 7 squared equals 16. Remember, it's always going to be our radius squared. Okay, let's try another one. Here we're going to write the equation of a circle with a center 5, negative 3, and a radius of 4. So here we do x minus 5 squared plus y. Now since our k value is negative, it actually becomes plus 3 squared equals, again, 16, our radius squared. In part C, let's write an equation of a circle that has a center at 0, negative 4, and a diameter of 72. So first of all, we know that the diameter is the distance from the circle through the center back to the circle. So our diameter is always going to be twice as long as our radius. So if you take 72 and you divide it by 2, we get a radius of 36. So just be careful. Sometimes you're not given the radius, you may be given the diameter. It's easy enough to find the radius, you just have to be aware of that. So now let's start writing our equation. So if our h value is 0, here we can just simply write x squared. We don't need to say x minus 0 squared. And then we have plus y plus 4 squared. Remember, if this is a negative, this is going to be a positive. And then here, remember, we actually have to put our radius squared. So it's going to be a larger number. 36 squared is 1,296. And that's the equation of our circle. All right, let's look at example D. So here we're asked to write an equation of a circle with a center at negative 1/2, negative 4, and a radius of square root of 13. So it's totally fine to have a center that's a fraction. We still treat it the same. So this would be x plus 1/2 squared plus y plus 4 squared. Notice both of these are negatives, So in our equation, it's a positive. And then here, remember we need to do our radius squared. So if you take square root of 13 and you square it, it's simply 13. The square cancels out the square root. Okay, so now we're going to practice graphing these equations. So whenever I graph a circle, I'm going to look at my equation, and I'm first going to determine what the center is. So here I can see that h and k are both 0. So we know that the center of our circle is at 0, 0. And we know that this value is r squared. So to find the r value, our radius, we take the square root of both sides. So that means r equals square root of 5. So I start at my center, and to sketch the circle, here's what I recommend doing. From the center, go directly to the right 5 units. Give yourself a mark. Go up 5 units, left 5 units, and down 5 units, and then do your best to connect that to make it look like a circle. Again, you can't count 1, 2, 3, 4, 5 diagonally because from here to here is not 1 unit. It only works when we're counting horizontally and vertically. So from here, you just have to do your best to make it look as much like a circle as you can. Okay, let's look at example B together. So here, let's start by finding our center. Here, since I see a plus 2, we know that our h value is negative 2. Here I see a negative 1, so we know that our k value is positive 1. So that's where our center is. So I'm going to start there. And then I see from our formula that r squared is 4, which means r is 2. So from the center, I'm going to go 2 to the right, 2 up, 2 to the left, and 2 down. And then I'm going to connect that into a circle. Okay, so now we know how to create an equation of a circle and we know how to graph it. So let's move on to example 3. So here we're asked to prove or disprove that the point 3 square root of 7 lies on a circle centered at the origin and contains the point negative 4, 0. So I know that if a circle is centered at the origin, which remember is 0, 0, and it has a coordinate at negative 4, 0, right here, we are essentially being told that our radius is 4. And again, we know that the center is at 0, 0. So for us to determine if this point lies on our circle, first we're going to make the equation for our circle. So our circle equation would be x squared, because x minus 0 squared, plus y squared, again y minus 0 squared, equals our radius squared, which is 16. Now if we want to see if this point is on this circle, what we're going to do is we're going to substitute this for x and this for y, and we're going to see if we get a true statement. So here we substitute x with 3, we substitute square root of 7 with y, and we're going to see if this is true. So 3 squared is 9, square root of 7 squared is 7, and we see that we actually get 16 equals 16. So that proves that the point 3 root 7 is on our circle. So again, to recap, we have to use the information we're given to make the equation of our circle, and then we can test to see if any point lies on the circle by substituting the x and y values and seeing if it makes a true statement. All right, let's move on to example 4. So here it says, suppose the circle with the equation x minus 2 squared plus y plus 4 squared equals 7 is translated according to this rule. What is the equation of the image of the circle? So let's interpret in words what's happening with this transformation rule. So this is essentially saying that we are shifting our circle to the right 3. X plus 3 means we're moving to the right 3, and then down 1. So you can see we're not changing the size of the circle, so the radius is not going to change. We're essentially changing the position of our circle. So our goal should be to shift the center. So from our original equation, we can see that our center, I'll say original center, is at 2, -4. Again, if this is a -2, this is a +2. If this is a +4, this is a -4. Now, if we want to shift our center to the right 3, we're going to add 3 to our x value. If we want to shift it down 1, we're going to subtract 1 from our y value. So now, that gives us a new center at 5, -5. So that means that all we need to do now is simply rewrite our equation, keeping the same r squared value, but changing our center. So our new equation would be x minus 5 squared plus y plus 5 squared equals 7. Again, we were not changing, we didn't stretch or shrink our circle, we only shifted it, which is why our r squared value did not change. All right, here is our very last example. So here we're asked to find the equation of this circle below, not to the right. So what we're going to start by doing is figuring out where our center is. So it looks like our center is right here. We can test that by counting the distance left, right, up, and down to make sure it's all the same. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this tells us 2 things. 1, it tells us that our radius is 5, and 2, it tells us that our center is 2, -1. So now we have everything we need to make the equation. X minus 2 squared plus y plus 1 squared equals 25. Remember, it's always our radius squared. And that's all there is to it. Okay, that is all for today's video. Thank you so much for watching.